So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to energy transfers and efficiency. What can be done with energy? Well, energy can be usefully transferred, but it's often wasted. It can be stored. It can be dissipated, which means spread out. Normally, it ends up eventually spread out to the surroundings as heat. But one thing that doesn't ever happen is that it can't be created or destroyed. So never ever use the words in an exam answer that energy is produced, because it can't be produced, it can't be created, so that means it can't be produced. That's always wrong, and it'll always lose you the mark. So, wasted energy. When energy is transferred, it's very rare for it all to be transferred usefully. Energy is nearly always wasted. Wasted energy is eventually transferred to the surroundings as heat. It becomes dissipated or spread out, which means that it becomes less and less useful to us. If less energy is wasted, then the efficiency of the energy transfer is increased. So how do we calculate the efficiency of a device? Well, there are two simple formulae. Both will be on the physics equation sheet. If you've got quantities of energy, then the efficiency is the useful energy that comes out of a device divided by the total amount of energy that goes in times 100. Or if you've got quantities of power in the question, the efficiency is the useful amount of power that comes out of a device divided by the total amount of power that goes in times 100. Sankey diagrams show the proportion of energy that's usefully transferred, and the key to these is they must be labelled. So you'll see on the left of that big arrow there you have to write the total amount of energy or power that goes into the device. So in this case we're talking about a light bulb here. Say 100 joules of energy goes in. Now over to the right it shows what proportion of that energy is wasted, which will be as heat, and the proportion which is usefully transferred as light. We want light bulbs to make light, not heat. So the amount of energy that goes in is 100 joules. The amount that's usefully transferred is 15 joules. That's the amount that comes out as light, which means that 85 joules is wasted as heat. And the Sankey diagram shows that in a visual way. One of the different forms of energy, you can have chemical energy, which is the energy stored in fuel and food, kinetic energy, which is the energy of a moving object, gravitational potential energy, which is the energy due to an object's position, for example its height above ground. Elastic potential energy is the energy stored in a squashed or stretched spring. Electrical energy is the energy transferred by an electrical current, and then we have sound energy and heat energy. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.